So today we are continuing our study of proportionality and talking about constant rate of change. If you need to look something up, this will be chapter 1, lesson 7. I'm also going to be using the textbook starting on page 66. So let's break this phrase down. Constant means that it's the same thing each time, over and over and over. It's going to change by the same amount. Rate, of course, is a relationship between two different variables. So say money and time, or distance and time, things like that. And then change is that it's going to change. There's going to be some kind of increase or decrease. And of course, because it's constant, we're going to increase or decrease by the same amount. Okay, so let's look at what this looks like. Sometimes you'll see it in a chart, and sometimes you'll see it in a graph. So in a chart, if you want to determine what the rate of change is, you need to figure out how much each thing changes. So in this case, we're talking about a car wash, a fundraiser. How many cars and how much money? So at the point in the day where we only had 5 cars, we had made $40. By the time we got to 10 cars, we had $80. 15 cars, we had $120. And 20 cars, we had $160. Now we're going to make the change for each of the variables, each of the things that could possibly change, right? The number of cars could change and the money could change. Those are our variables. So each time it looks like we added 5, right? Plus 5, 10 plus 5, 15 plus 5. And then over here on the money, it looks like we added $40 each time, right? 40 plus 40, 80 plus 40, 120 plus 40. Now, since this was a constant and this was a constant, I'm going to make a fraction to figure out what the rate of change was. So a lot of times we talk about money per car, how much money we made per car. So this change, the $40, went on top, and then the number of cars went in as our denominator. Well, we can simplify 40 over 5 and figure out that we made $8 per car. Now, if I was to change a different amount, instead of saying plus 5 here, maybe I said plus 2, then I would have to change by a different amount over here. I could not change by 40. But each time we added one more car, we added $8 more. All right, let's look at that on a horizontal chart. I'm going to go to dotted A. So we're talking about the number of miles a plane traveled while in flight and how long it took to do that. So you can see your time, 30, 60, 90, 120, and your distance. Okay, let's check the change. This looks like we added 30, right? 30 plus 30 is 60. It feels blurry. Maybe I can fix that. That's slightly better. Okay, then we're going to do plus 30 again because 60 plus 30 is 90. And then plus 30 again because 90 plus 30 is 120. So each time, 30 minutes had gone by. All right, now this one, I think I'm going to bust out the calculator. And I'm going to subtract. I'm going to do 580 minus 290. That tells me that we added 290, right? 290 plus 290 is 580. Now, let's see if I do 580 plus 290, do I get 870? Yes, I do. So we added another 290. And if I do it again, does it give me the last number in the chart? Yes, it does. So each time we were adding 290 miles. Now, they want miles per minute. Let those labels help us set this up. Okay, miles per minute. What was my change for the miles? 290. What was my change for the minutes? 30. Now, this is a speed. I don't really walk around saying, yes, I went 290 miles per 30 minutes. We just don't do that. So let's divide these to figure out how much it will be for 1 minute. The unit rate. 290 divided by 30. I got 9 and 2/3, or 9.6 repeating. All right? So roughly 9 and a little bit over 9.5, almost 10 miles per minute. Approximately 10, 9, something like that. Okay, let's look at the other way that we can show this with a graph. Now, when I look at this, take out these boxes and all these labels for a second, and I say describe this graph to me, you're going to have a hard time doing it because the answer I'm looking for is super obvious. And you're like, it couldn't possibly be that easy. That makes a line. And if you remember back at the beginning of the chapter, we were looking for things that made a line. If there was proportional or proportionality, it would make a line and it would go through 0, 0. Okay. Now, sometimes this can be a little challenging. If you look real carefully, I'm going to try to zoom in to prove my point here. If you look super carefully, this does not cross at a nice, pretty point on the graph. I'd have to estimate, I don't know, maybe 25, 28, I don't know. But if I look here, that crosses at a beautiful point on the graph because I can clearly see that that's the line for 1 and that's the line for 60. Okay, so wherever I see nice, obvious points, those are the ones I want to use, right? And then we're going to count. Usually you count up first. I know it's completely opposite of how you graph. I'm sorry. There's no way to remember that except to just remember that, right? From one point to the next. So let's start here. If I go 60 miles, I go 1 hour. All right, now that was 3 lines and 2 lines. So let's see. If I go up 3 lines, 20, 40, 60, and over 2 lines, half an hour, look at that, I land back on my graph. If I go up 60, 20, 40, 60, and over an hour, half hour, hour, would you look at that? I landed right on the line again. All right. So each time I went up 60, I changed by 60 miles, and I went over an hour. So it's 60 miles per hour. Now, you can also do this with subtraction. If you're not good at the counting, if that always messes you up, find the coordinates and subtract them. So for example, I'm going to pick 2 that actually have numbers here. This one and this one. This is 1 comma 60, right? Over 1, up 60. This is 2 comma 120, over 2, up to 120. I'm going to subtract them. So 120 minus 60 is 60, and 2 minus 1 is 1. So there's that 60 over 1 again. Okay. Now, why am I going up first? Why am I doing the second number or the y coordinates first? That'll actually come in the next section. If you can just trust me for right now, they will become very clear to you in the next one, in the next section. Okay. All right, let's drop down to the got it C. That was a really bad camera move. There we go. That's a little bit better as we focus. Okay, so this is measuring the distance and the time that it takes to go that distance. I'm going to pick 2 points, any 2 points that happen to fall on that line, like this one and this one. Now, luckily, they gave me the numbers because those I would have to estimate. I guess they're halfway in between, like 80 and 100. Fortunately, they gave me the numbers, so we're good. Okay, so we're going to do the y's on top and the x's on the bottom. We're going to do the right numbers first and the left numbers second. All right, so let's see. I have 90 minus 30. And then in the same order, I'm going to do 3 minus 1. Right? I did the top point minus the bottom point. I could have done it the other way, but then I'd have negatives, and I don't feel like dealing with that. So when I subtract, I'm going to get 60 and 2. And when I divide, I'm going to get 30 and 1. So that is 30 miles in 1 hour, or 30 miles per hour. But what happens if I pick different points? What happens if I picked the 260 and the 130? Let's try it. I would do 60 minus 30, y minus y, and 2 minus 1. Well, that's going to give me 30 on the top and 1 on the bottom. It's the same answer because it's a constant rate of change. The line was a straight line. It wasn't zigzaggy, changing all over the place. It changed by the same amount every time. 1 hour went by, 30 more miles. Another hour, 30 more miles. Same thing every single time. A constant rate of change.